Okay, we'll wait a couple more minutes to let everyone get set up. I think we got one, two. I think we're supposed to have 11 or something like that, but I imagine some people are watching from home. Yeah, question? Mm-hmm. Well, they're due at 11:59.
So we said it was due at 12:43 p.m.
Oh.
I said the same thing when I have to turn it in.
Okay, I just missed the date, so hold on. Let me change that. Yeah, you're fine. It's supposed to be due at midnight. Let me change that real quick while we're waiting. That was number 2.
Yeah, it was number 2.
I apologize for that. Yeah, so in the future, if you ever see that, because it defaults to whatever time I enter it in, I try to remember anyway, but there's so many settings on here that I have to change. If you notice that if it's set to anything different than 11:59, just shoot me an email and just assume it's due at the end of the day, okay? So that one's correct. And then let me just check the other class just to make sure that I didn't mess up theirs. Nope, just messed up yours. Okay, I apologize for that. Okay, let's go ahead and get started. So if there's anybody showing up late, they can get set up while we're doing announcements. So I know I still have to grade assignment number 1. Assignment number 2, for anybody who hasn't completed that yet, I know we were just talking about that, that's going to be due today by the end of the day, so 11:59. Any questions about that? Or any confusion about anything? Okay, that one should be fairly straightforward. And then we have a new assignment today that's going to be due in 1 week. It should look pretty similar to the last one. The only difference is that this one you need to be able to go either direction. So it's going to be menu based, and that'll be our first example is that we'll do a menu based program. And I think we did one at the end of class last time, correct? One of these menu based programs. So, but we'll just kind of as a refresher, we'll do that. Don't forget, if for some reason you fall behind, the lectures are recorded. So let's just make sure this is actually going. Yep, streaming, no drop trains, perfect. And then also, if you don't necessarily need to rewatch the whole lecture, you just kind of, some examples just not working for you for some reason. Don't forget that I also post the actual source code from class. Okay, not too many announcements because we're only a few weeks in, and I know I got some grading to do, and then I'll try to get that assignment let's do today graded as well. But if there's no questions, I guess we can get started. So let's go right into resources, REPL, and let's start off with our hello world that we always do. So over time, I'm going to make these fonts a little bit smaller as the examples get more involved. I think this is slightly smaller than we had before, but this is still okay for everybody, correct? So to start off today, let's do the last time we did the miles to kilometers or kilometers to miles. Let's do liters to gallons and the other way as well. Okay, we haven't done that one yet as a menu program, correct? I checked our old examples. I don't think we did. So let's just search for that. So this one's going to be liters to gallons or gallons to liters based on the menu. And let's say that 1 liter is some number of gallons. 1 gallon is some number of liters, and let's look that up real quick. I use these so much you'd think I'd have these memorized. 1 liter is So the idea is that we have menu-based programs, that they give us some input using CN. Remember how CN works is that I grab the input from the keyboard, and then we're going to use if statements to decide what the menu choice is. So if they press number 1, if they press number 2, and so forth. And then we're going to do some code execution based on that. It's called conditional code execution. So at the very least, we know that we're going to be dealing with gallons and liters. Why did I use a double? Because theoretically somebody might want to convert 1.5 gallons. And then actually they both need to be, because if I do like an exact number, like enter in 1 gallon, that's going to be a decimal number of liters. So it wouldn't calculate correctly if, well, yeah, it wouldn't. Okay. Now with these menu-based programs, I'm going to tell you ahead of time, and you might remember this from last class, is that what we want to do is we want to create a variable called choice, and we want it to be an integer. We don't generally want to use a string with these, is because strings can cause problems. Even a simple yes or no question, somebody might interpret it many different ways. So it could be interpreted as y, capital Y, lowercase y, the full word yes, and then all the different variations of that in capital and lowercase. And so it generally just becomes easier just to use numbers, at least initially. And so we're going to print out our menu. You're going to see these patterns over and over again. So this is a simple menu. We ask them to enter the choice. Don't forget some of this first and second week stuff that we've done. Remember end-else, how they work? And you know, if I'm asking them to enter in something, it might be a good idea to leave off the end-el, because in my opinion, it's probably good to keep the cursor on the same line. But don't get caught up in some of these basic things. Remember I told you initially that conceptually a lot of this stuff is very simple. It's when you add layers and layers and layers and layers that you always have to remember everything, and just understanding the concepts and understanding the concepts alone isn't enough. You have to be very fast at all this. Remember the basic stuff, which direction the arrows face. Okay, so with C out, it's taking all the stuff here, it's streaming it out to the screen. C in, it's taking in from the keyboard. Remember some common mistakes is that sometimes people just get into the pattern matching of always having end L at the end. This doesn't really make sense or have any context. Okay, so little things like that. And we don't want to write too much code without testing it. Even though it's not going to do very much right now, I still want to at least test it. So we started off our program last time. We said, okay, if choice is equal to 1, remember these two equal signs mean equality. One equal sign means assignment. assigning it this value. I'm setting it to this value. 2 equal signs is more like what you're used to in algebra. It's like a balanced equation. You're checking to see if the thing on the left is equal to the thing on the right. Okay. And so if they entered in choice number 1, we know that they're going to supply liters. They're going to give us liters. They want gallons. So we're going to ask them for the number of liters. We have to store that somewhere. Where do we store it? Inside of this variable liters. We do the conversion. I know I'm going a little bit fast on these. We've just done these so many times that it's just kind of like mechanical at this point. We're going to say that gallons is equal because this is what we want to calculate, and they've given us liters, and then we know this number to multiply it by. So we're going to say it's going to be times 0.264, so 0.4. And then we'll just do a simple C out. It's always good to do a quick mental check on these, by the way, too. That's what I was doing just to make sure I didn't have my directions backwards. Is if they enter in 1 gallon, that's going to be, I'm sorry, if they enter in 1 liter, a liter is smaller than a gallon, right? Like think about like a bottle of soda. Like you might get like a liter of soda. That's going to be smaller than a gallon. And so if I entered in, let's just enter in as a test. So I want to go liters to gallons. If I have 1 liter, that should be a small fraction, a smaller size. It's about a quarter, which seems about right. Now, if you remember from last time, what we could do is we could stuff all this choice number 2 inside of an else, but what problem did we have when we did that? Does anybody remember? What if I enter in choice 2? This works correctly, right? But what if I enter in choice 3 or 4 or 5? It always thinks it's that choice, correct? So what do we use instead?
Else if.
Else if, perfect. And same thing here. We're going to say enter gallons. We're going to enter in gallons from the keyboard, and we're going to store it in our variable gallons. We want to give them back liters, so that's what we have to calculate. And they've given us gallons times 3.78. And again, that makes sense because 1 gallon is probably going to be a bunch of liters, right? Because it's larger. So that makes like some quick, passes a quick sanity check. If we enter in an invalid choice, like 3, it silently fails. So what do we want? The else. Remember how all this works is that, just taking a step back while some of you are typing, is that the stuff between the parentheses has to be either true or false. Most of the time it's just like a simple comparison like this, but there are times where it can coerce and try to come up with a true or false value, but there's no third choice. It's either true or false. If it's true, it executes the code between the curly braces. If it's false, it doesn't. With an if, else, if, what happens is that, okay, this wasn't true, so I go over here. Choice number 2, if I did press the number 2, it would say, okay, execute this code. Now, because one of these executed, the else doesn't have to run, and then it goes to line 36. And so we could always do something like this. That no matter what we enter in, like say an invalid choice, it's always going to print line number 37 because that's outside of the curly braces. The order of that is important. I can't do an if, else, else if, like there's a very specific pattern. It should be pretty obvious. What you do is have one if statement, then 0 to infinity else ifs, and then 0 or 1 else. Now, I generally recommend to have an else at the end because it kind of is a catch-all. And usually that's where you do your error processing, is that you'll have one final else at the end. And if they enter an invalid number or something weird happens, that's where you could handle that. Everyone's good with this idea of conditional code execution? Only when this thing is true does this code execute. So far, we've just been doing comparisons, and that's generally what you do. You check to see if something is greater, less than, greater than, less than, or equal to, greater than, less than, and then finally this one, the double equals, which is equality. And note that this is different than assignment. Single equal sign, what that does is it gets a value, and then it stores it over here. What this does is it's more like a question. It's saying, is this thing equal to this thing? Okay, any questions on that? So up to this point in the course, I've been kind of vague about certain things. One of them is that we went through this process early in the course where I said, okay, I named a bunch of numbers. I said 2.5, is that a double? Yes. Negative 3.7, is that a double? Yes. But 1.0, is that a double? Yes. So why do we even need ints if we could just represent everything as a double? Well, the simple answer is, in this case, they're not going to enter in choice 1.5. It really only makes sense as a whole number. So we could do that, but really, I mean, why even have ints, though, if I can still represent everything that I need to? So let's start a new example, and hopefully it'll make a little bit more sense. So don't type this right away. You'll type it all at the end, but sometimes I like to go through examples where I just kind of do some things and talk, and then, because this isn't really like one of the conversion examples like we normally do. This one's just, and I guess you could type the hello world just to get the skeleton going if you wanted to. Most of the time we'll do very complete examples like we just did with the liters to gallons menu based program. But every once in a while there's like a specific concept that I want to show that doesn't really fit into anything. And so I'll just show that in isolation. That's what I'm going to do now. Okay, so don't worry about typing any of this yet. Like I said, you can do the hello world if you want, but let's say, for example, I've got two variables, A and B, and another variable called result. And I want to just do something very simple. Result is equal to A. Sorry, so let's assign it values first. So we'll say A is 0.1, B is 0.2, and the result is A plus B. Then we say, okay, well, if result is equal to 0.3, see out match. So don't run this in Sheet, but let's talk about this. So just going through the logic without running the code, any sane person would think that 0.1 plus 0.2 is equal to 0.3, correct? Yeah. Every math class I've ever taken, that would be the normal answer. So, on planet Earth, you'd think that it would print match, correct? Because it would say, okay, is 0.3 equal to 0.3? Yes. But it say didn't match. It's very strange. So let's take a step back and let's see what result actually is. Well, it's 0.3. That's really weird. Let's do something else here. Well, I think I have to do an include for this. There we go. I think I set it to, this should be enough. Maybe that's too high. Hold on. Let's try 20. Hold on. I might have done it out of order. Sorry. There we go. The number isn't 0.3. What's the full number? 0.3 and then a bunch of zeros and then some stuff at the end. Does this make sense now that it's saying, I'm not saying is 0.3 equal to 0.3. What I'm actually saying is this number equal to 0.3? And is that number equal to 0.3? Yes or no? No. So you might think that's super weird. That's why would they write a programming language to do that? When these languages were created, most programming, so you're thinking like just after World War II, so like 40s, 50s, the types of programming that they were doing tended to be related to like physics. And so in physics, it's generally okay to be off by a little bit, as long as you know how much you're going to be off by. Does that make sense? So you can like set a precision. It's not like an algebra class where it's symbolic math, where you like represent everything exactly. In physics, it's pretty common that you have some sort of precision, and then you just have to know what your plus or minus, within the precision that you're at. So when they were creating computers, they had two choices. They said, when I'm using decimal numbers, do I want a version that is exact, or do I want a version that's fast? And think about the computers, how incredibly slow they were back then. So that saying that I want a computer that is exact, that might have been the difference between a calculation occurring in hours versus weeks. And so they made the decision very early on that this thing right here, this double, this was going to be very fast, but not necessarily exact. And so what they did is they came up with this very complex system of representing, not so much complex, it's just not intuitive to most people, of representing these numbers as base 2. Computers are very fast at base 2 because on and off, right? We've got switches, we've got binary. And so it uses a format that's very fast for the computer to work with. Fast forward into, like, let's say the 70s and 80s, when people started using computers for accounting. Is this sort of thing acceptable in accounting? Is it okay to be off by a penny every once in a while in accounting?
No.
No. You have to be exact every single time, even being off by a penny. I've worked at places where literally at the end of the day, a report was off by a penny and they had to track down for the auditors why it was off by a penny. Especially when it's a computer glitch. That makes everyone really panic because it's different when it's like somebody's cash drawer, you know, pennies go missing, but when a computer makes that mistake, you're like, is the program not right? So built into the languages is these very fast decimal numbers, but not exact. Now, when you get into the real world, this is generally not a problem, except for, like I mentioned, anytime you're dealing with money. In this class, we're going to be lazy about it. We're still going to use double for money. But in the real world, the way you would solve this sort of problem is if I needed to represent 30 cents, what I would actually do is represent it as an integer. There's a couple different ways. One of them is just represent everything as an integer and then only work with cents. That generally works. It can complicate some things. But most programming languages actually have some sort of native decimal type, like C# and Java both have that. And then they're slower, and you don't tend to use them by default, but if you're writing any sort of accounting program, you would use those. But C++ doesn't have that, so if you're writing a program dealing with money in C++, you'd probably just use cents for everything and just use an integer. But I just wanted you to be aware of that. The couple of takeaways is that when you get out into the real world, don't try to use double for money, because you're gonna get into a situation where it's like most of the time it works. And by the way, notice that I chose these numbers very carefully. It's because sometimes it works, sometimes it doesn't. The example I like to use is, can I represent 10 divided by 3? Can I represent that as an exact decimal number?
10 divided by 3? Yes, as an exact decimal. Yeah.
So plug that into a calculator. 10 divided by 3.
No.
Yeah, what do I get? So I can represent it symbolically exactly, right, 10/3, but at some point, the computer is going to have to cut off and say, this is the value. It's sort of the same thing, is that we've changed from one system to another, and that's what happens here, is that we're changing from this base 2 floating point number system to where we want to actually, as people, be able to see the number, and then there's kind of something lost in that process. And then the other takeaway is don't use this with equals, because every once in a while you're going to get into situations like this. Does it make sense now why we have integers? Integers you can actually do, we won't ever run into the situation with an integer. We can always have an exact representation. That's not the case with doubles and floats. So going back to this example, even though, yes, I could have technically represented it as a double, I might have ended up in weird situations where somebody presses choice number 1 and then I get invalid input. I don't want you to think this is always the case, because I had to go to some effort to research some numbers that would work for this. It's not always going to be the case, but it's often enough that it's like maybe a couple times a year if you're trying to do these equality comparisons with doubles. And to be honest, it'd be better, I think, if the languages just threw an exception or gave some sort of warning or something like that, but they generally don't. Okay, any questions on that? I'll let you type this up, by the way. I know I said I'd give you some time, so go ahead and type that up just so you have that example. Don't forget at the top, let me scroll up here. You have to add this thing, IOmanip. It's so you get this special function called set precision, which gives us the actual full version of that. By the way, if you ever have a lot of time to waste, there's a whole bunch of information on it. Hopefully now you can see why I don't throw this at you the first week of class. It's like you're just trying to learn the basics of the language, and it turns out to be some things end up being kind of complicated. Okay, any questions on this? Yes.
Can you move the top so that supposition can be used?
Okay, is everyone good on typing? So I'm going to do a very small example while we're on the subject of how doubles work. And this one's short enough that you can just type it, I guess. It's going to be another like isolated example. So we'll be very generic. We just had double some number. And we're going to say that number is 5 divided by 9. So who expected 0? Probably not very many people, okay? By the way, on the assignment, this is the reason I made such a, I said don't use, and it should be, I think, like 0.5556. This is basically from the assignment. But you got 0. Now if I plug that into a calculator, I get that number, which is what you used for your assignment. So what happened? So your first thought is, well, maybe it rounded. But does that follow the rules of rounding? If I had rounded, what would it round it to? It would have rounded it to 1, correct?
Yes.
So that's not it. Well, what happened? This is actually called integer division. And remember at the beginning of the course, I give it an example with like addition, subtraction, multiplication. And then I was kind of weird about division. I said, don't worry about division right now. It's because when you divide an integer by an integer, the result is an integer. And that's exactly what we got. We got 5 divided by 9. And what it did was it said, oh, well, the result is a double when I do the operation, but because you've done integer division, you must want an integer. So what did it do? It went through a process called truncation, where everything after the decimal point. It didn't do anything smart about it, like try to round or anything. It just wiped it out. And then so what were we left with? We were just left with 0. How do we solve that? Well, one way is that, so 5 and 9 are both integers. However, we've sort of talked about this before. What are 5.0 and 9.0? Those are doubles, correct?
Yes.
Now all of a sudden, this works. Now the tough thing that I've had over the years, problems like convincing people, is that it's not super obvious all the time, and these problems don't crop up. So all that has to happen is that there has to, for integer division to all of a sudden become promoted to floating point division, or double division, I guess for this class we could call it, only one of the numbers has to be a double. So let's do this. I should get the same exact result, correct? If you just multiply some number by 1, it's just that number. And yet it works. So what happened? Remember our order of operations. What gets multiplied, or what operation happens first? It's going to be the 1 times 5, correct? What's the result? That's going to be a double 5.0. Only one of the numbers has to be a double for the whole thing to get promoted to a double. That's why these problems don't always crop up right away, is that you can end up situations where I multiply something and I get a double, and then I divide it by, and I involve this operation somehow, and it seems to have worked. So in this class, I'm going to make a blanket rule that anytime you do division, and in general, it's most likely going to be we want to divide by doubles, is that make sure 100% that it's a double. Even if by chance the mathematics work out and you get the correct answer, as a blanket rule, and I will take off points for this because this is just, subtle bugs are the most difficult because they don't always show up right away, and they, like, maybe 1 out of every 1,000 times somebody uses the program and it's like just a little bit off. So you have to be very careful about these sorts of bugs. And usually I'm pretty, I try not to get way too much into the weeds and details, but integer division is one of those that I've seen a lot of people make mistakes and they just don't understand. It's like some numbers work and some don't. So just always force yourself, if you're going to do division, make sure that both things that you're dividing by are going to be doubles, okay? Okay, and that's a short example. I just wanted to explain that. Any questions? Okay, so let's go back to our conversion type programs. Let's convert years to hours. That one should be, again, pretty straightforward. 1 year, 2. So this one's going to be years to hours. And let's do this. Since we're doing good on time, I only have a couple more examples after this. I want you to try to go through and let's say we'll spend 5 or so minutes Try to go through that process that we've gone through a bunch of times before. But the one thing is, I want you to make sure that the number of years that they entered in isn't negative. So only accept positive numbers. So if years is greater than 0. Go through that process. Think, okay, what variables do I have to declare? What data types? Remember how to do an if statement. And then we'll go over the answer. Okay, so first thing, we need to decide what data we need to store inside of variables. So what are the variables that we'll need to create, and what data type are they?
Years and hours and both those.
Perfect. So I'm going to be storing the number of years, because they're going to give me years. And by the way, this is not like one of those two-way versions. This is just years to hours. And we're going to say enter years. Right, yeah, so they're going to provide years, we're going to give them hours. So if they enter in 1 year, it's going to be this many hours. And then finally, cout Now the goal was that I should keep from the user putting in invalid input, because the idea of minus 5 hours doesn't really make sense. For, you know, obviously in certain contexts it does, but for this it's kind of a silly input. And then it does minus 5 times this number. Does the math right, but that's not what we want. So what do? We surround it with an if statement. So we say if, so we have to do that after they've given us years. By the way, that's good that I almost typed it like that. The order of this stuff does matter. So if I had wrapped this entire thing with this if statement, so don't type this because this is incorrect. What would have happened? It's kind of not clear, because at this point in the program, at line number 12, if years is greater than 0, have they given us the number of years yet? No. When do we actually get the number of years? What line number?
14.
14, exactly. This is where we get it from the keyboard. So it's kind of like we end up in a situation where we're trying to do a comparison on something, a piece of information that we don't have yet. Okay, so be very careful of that, because you'll get into, it's like, you end up in weird situations like that where the number, whatever bits happen to be there, happen to be greater than 0, but it's not really what we want. So what do we want? We want to put this over here, because at this point we do have the number of years. Okay, clean that up a little bit. And then, like I mentioned before, it's always good to have this else that says invalid input. Nothing super interesting about this example. I just wanted to make sure you remembered how to do comparisons that are greater than 0, because it'll lead us into our next example. Just kind of a review, I guess, if nothing else. Any question on that example? Let's just, I guess, make sure it actually works. Type in minus 5, perfect. 5, that seems about right. Okay. So let's do another program. I think we've done some variant of this before. Let's do the area of a rectangle. Hopefully you remember how this program works. It was the area is just going to be the length times width. So they need to provide the length and the width, and then we're going to calculate the area. Follows the normal pattern as usual, so we say cout, enter length, enter width, and then we calculate the area, which is just length times width. Shouldn't be anything that interesting. I think we've actually done this exact problem before, and let's just confirm it works. Everything looks good. But we end up in kind of a weird situation that we've been able to solve before. Like here, if I enter in minus 5 years, over here, I had the if statement to catch it. Here, I don't have an if statement yet. And then so, again, in certain contexts, negative length might make sense, but in this case, it doesn't. Did the math correct, right? Did minus 5 times 5, which is negative 25, but okay, well, how do we solve this? Well, we could say if the length is greater than 0, do the calculation, and that solves part of the problem. I don't have my else invalid input. So if I enter in minus 4 or 5, I get invalid input. But what happens if I enter in 4 minus 5? I'm not able to catch that. Now I could put an if statement inside of here and make it kind of complex, but we actually have a special tool for that if we want to check for 2 things at once, essentially. Let everybody catch up on typing. And so what we can do is we use these 2 ampersands, which mean the word and. So we can check that the length is greater than 0 and the width is greater than 0. So let's think about the different possibilities. Okay, if they're both positive, that's okay, that worked correctly. Minus 5 plus 5. Perfect. 5 minus 5. And then the last possibility is when they're both negative. So there are 4 possibilities, and only one succeeded. Only one actually executed this code right here. Does it make sense? Yes.
You could nest ifs, couldn't you?
You can. What ends up happening is it gets a little bit difficult to read.
Okay.
So like you can actually chain 3 of these in a row, and if you had if and an if inside and an if inside, it gets kind of difficult to read. But you're correct in that there are times that that's the correct thing to do. Yes.
Can you just keep adding ampersands? Like if you had more values, like if you're calculating area, you need to add one, you need to add another ampersand and add height, and that would work.
Exactly. So for those that didn't hear in the back, if you wanted to, exactly, you could, and don't type this because we don't have the variable height, but we can, if we did have height, we could also check to see that height is greater than 0. It's giving an error because we don't have that, but you could just keep on chaining them together. Has anybody ever taken like a logic class where you've done truth tables? Okay, so I'm not going to talk about it in that term. But basically, the only time, remember that the values inside the thing inside of the parentheses of an if statement, it has to either be true or false. This is very obvious, something that can be either true or false. Either it is, since length we know is a number, it either is greater than 0 or it's not greater than 0, true or false. Same thing with width. The width is either greater than 0 or it's not greater than 0, true or false. So what we do is we get, when both of these things are true, and it reads in English pretty easily, is that if length is greater than 0 and width is greater than 0, so both things have to be true, then it runs the code in between. Sometimes I get a little overly formal explaining this because it's actually an area of math called Boolean logic. But I think that's maybe not productive today, so I'll hold off on that, maybe another time. Okay, so, but to me this reads pretty naturally. Any questions on this? Okay, does anybody need a little bit more time typing? Okay, so I got one more example I want to do today, and we may have time that at least you can get started on your assignment. And that way, if you have any questions, you can, I mean, not much, we might have 5 minutes, but at least let you read through the assignment and kind of make a plan for it. Okay, so this last example I like to call the car rental example. So let's start off with a hello world. The question I get a lot is, so this, I like this example because it actually, a few years ago, started off an example that there was an error in it, and it was just an example I made up on the way to class. I was like, oh, that'll be a good example. And then actually ever since that, it's been a good example to show a bunch of things. Every once in a while I make mistakes, and then it's like, it's a good opportunity because people don't write perfect code all the time. It just doesn't happen. And so it's a good chance to kind of like look at common mistakes. The question I get asked a lot is, couldn't I just write this as 2 if statements? It's like, what's the difference between an if and an else if? Everyone kind of sees how the question is framed, correct? Like, what's the difference between saying if choice is equal to 1, else if choice is equal to 2, versus if choice is equal to 1, if choice is equal to 2? And in this case, it doesn't really, I shouldn't say it doesn't matter, it's just not super clear. So I came up with this example to make it a lot more clear. So let's pretend that we are a car rental agency, and they have all these different rules, but let's say, for example, that if you are 18 to 25, that you can rent a car, but there's like a special fee. Like you have to purchase some extra insurance or something. So we'll just very generically say fee. Can rent, but then you have a fee. 25 and older, you can rent, no fee. And then everyone else can't rent. So even though you might have your license at 17, this car rental agency just won't rent. By the way, I'm going to introduce mistakes, and if you spot them, just hold off on it for a minute because I want everyone to get a chance to like really think through it and see the problem. Okay, so what we'll do is say int age, and here I chose int because does it really matter if the person's 18 and a half? Not really. It just matters that they're 18 or older. So in this case, age is okay as an int. And so we start going through our logic. We say, okay, if age is greater than or equal to 18, they can rent, but they have a fee with the fee. Else if age is greater than, is greater than or equal to 25, you can rent without the fee. And in all other cases, they just can't rent the car. Seems like a pretty straightforward setup for our program, correct? And again, don't shout out anything. I want everyone to get the chance to run through this. So type it. Don't run the code just yet. Get it typed out. So I type up my program, I start testing it, no syntax errors, so it runs and I enter in 19 and it'll say I can rent with the fee. Seems like everything's great, right? If I enter in 17 and then I might say, okay, let me test 26. That's weird. What did our rule say? At 26, I'm supposed to be without a fee, right? Does anybody see what happened?
Yes.
So why did it do that? If I enter in 26...
On the if statement, the age was just greater than or equal to 18.
Exactly. So the point of this example is that the ordering of all this stuff does matter. Because in this case, yeah, we wrote this else if here, but it actually never gets executed. Because if you think about... I try not to get too much into algebra, but think about like a number line. If you drew out a number line, everything that is greater than 18 is also greater than 25. Does it make sense? So if we do this first, what ends up happening is, 26 is going to match. So in this case, the fix is relatively simple. In practice, what I usually like to do is use the ands, those two ampersands that we just did, and I like to bound it from both sides. But let's keep life simple for right now, so we'll just switch around our program a little bit. So here we'll say that we'll check 25 first, and then 18, and then we just switch up the with and without. So the two things I changed here is the age oops, sorry. So 25 is first. And then the other thing that I changed is just to make sure that this little cout statement makes sense. And now when I run it, the first thing that happens is that if I enter in 26, this happens. Okay, and let's just check some other ages just to make sure they still work. So the next question related to why do I even need this if, else, if stuff? Why can't I just do a bunch of if statements? So let's do this. So don't change your code because I'm going to change it back. Now if I enter in 26, we're in this weird situation where it printed both things. It's like in this weird state where I can rent with and without the fee. The way these work is that with an if statement, if I have an if, else if, else, that sort of structure, the very first thing that matches will cause the rest to not be checked. So what that means is if I had this if, else, we can type, okay. When I entered in 26, this thing matched, so none of this other code even was checked. Does that make sense? Versus if I have two separate if statements, it checks this, and then independently, regardless of what previously happened, it independently checks this. That's why if I enter in 26, it says, okay, is age greater than 26? Yes. Is age greater than 18? Yes. But it's not until I have this if, else, if that it says, okay, 27 is greater than 25. I'm going to execute this code. I don't need to worry about any of this other stuff because this first one matched. Okay. And that's why we have if, else, ifs, is because of that. It's whether they independently check or if they're a part of a big chain of like of a code block. Okay. So I think that's pretty much it. Any questions that you have that you want to